Derive the set identity A union A intersection B equals A from the properties listed in theorem 6.2.2, laws 1 through 9. Start by showing that for every subset B of a universal set U, the universal set U union B equals the universal set. Then intersect both sides with A and deduce the identity. Now, that hint right there pretty much gives it all away for us. Let's start by proving that this is true for every subset B. Now, we're not allowed to use Rule 10, Rule 11, or Rule 12, but we won't need those anyways. We could start with the universal bound law, which says that A union the universal set is the universal set for every set A, and that includes set B. So by the universal bound law, we immediately get that the universal set union the subset B equals the universal set U. Then we have to intersect both sides with A. Now, if you've ever taken linear algebra before, you'll know that when you multiply matrices on both sides of an equation, you have to specify which side of each side of the equation you're multiplying that matrix by. You can say, I'm multiplying both sides on the left side, which is a way of saying you're multiplying a matrix on both sides of the equation, but specifically on the left side of the expression. The same thing is true about applying set operations to both sides of an equation. So if we want to intersect both sides with A, we also have to specify which side of the expression we're intersecting A with. Now, to make this problem a little bit easier, I'm going to specify that we're going to intersect A on both sides of this equation on the left side. And so if you notice, A is on the left side of both sides of the equation. So we're still intersecting A on both sides, but we're doing so on the left side of each expression. Now, this is not the identity that we're trying to prove. We're trying to prove that A union A intersection B equals A, and that's not what this says. However, what we can do is we can apply the set identities to both sides of this equation. In particular, I think we should start with A intersection U. Now, this right-hand side is A intersection the universal set. And in particular, the identity laws tells us what happens when you intersect with the universal set. It doesn't do anything to the set. So A intersection U by set identity number 4 is just A. And that is the right-hand side that we want. So now we just need to fix the left-hand side. The reason why I took the intersection of A on the left side of each equation is because now everything is set up to apply the distributive laws. Now here we have A intersection the universal set U union B, and this is A intersection B union C, which is not quite what we have, but again, this is a formula, meaning that you can replace A, B, and C with anything. We can replace A with A. We can replace B with U, and we can replace C with B. And the distributive law tells us how to distribute this A intersect to both sets here. So this turns out to be A intersection U union A intersection B. And this is still equal to A. The right-hand side is still the same. Now here we have A intersection U, and we can apply the identity laws again. So by set identity number 4, we can say that this is just A union A intersection B. And that's how we derive this set identity. Thanks everyone, and I'll see you in the next video.